Hello again everyone, welcome back to ptet.chemistry channel. This is a continuation of this section B kind of MCQ where we compare statements, and we have option A being 1, 2 and 3 relevant to what they're asking. B is 2 and 3, 1 and 2. C is 2 and 3, and D is only 1 is relevant to whatever they're asking. So 10.4 is just my classification for alcohols, and it's very easy to see straight away these are on alcohol topics. So in this question, we have this compound. It's an intermediate in the manufacture of pen. I think there's just a background information. But what is essential about it is they're asking for which information or which statement about it are correct. So it says number 2, if we check number 2, because with this kind of logic, we always check for number 2 first. I think if you've done enough practice, you should know the logic, and your school teacher will have taught you to do so as well. So if we dehydrate by corn sulfuric acid, so we're going to remove OH. So to do dehydration, this OH is on this carbon. We are forming an alkene, you see, we are forming an alkene. So we are looking not to remove the H from the same carbon, but the H from the next carbon. If you are here, your next carbon is here, and this next carbon is bonded to carbon. There's no hydrogen on this carbon. The carbon formed 4 bonds already to 4 other carbon. So this OH is bonded to a carbon which is bonded to the next carbon with no hydrogen, no neighboring hydrogen. So the neighboring carbon in the paper 2, you will say the neighboring carbon to the carbon with OH has no hydrogen, therefore cannot eliminate. Therefore, you cannot eliminate H2O. If you cannot eliminate H2O, you cannot dehydrate. So that means 2 is incorrect. And if 2 is incorrect, by logic, only 1 is correct. Okay? So in the last 10 questions, you could have moved on once you satisfy yourself that 2 is incorrect. But I'll just check and confirm for you that number 3 is actually incorrect. Yeah. So the empirical formula, so we can work out the molecular formula, which is the actual number of atoms in one molecule. Okay, actual number of atoms in this molecule. So total it up, you have 5 carbon. You have 2 hydrogen plus 3 hydrogen plus 1 is 3. So you have 3 times 4 is 12. So there's 12 hydrogen, and you have 4 oxygen. You can't simplify 5 is to 12 is to 4. 5 is a prime number, okay? A prime number can only be divided by itself and 1, okay? So you can't simplify to CH3 or at all. So 3 is also incorrect, okay? But by logic, you will have checked 2 first, and you have gotten D as the answer. So next bit, we have which compounds are able to react with corn sulfuric acid to give a product. So each of these is an alcohol. Well, this is a carboxylic acid. The next one is a carboxylic acid. So the carboxylic acid doesn't get dehydrated with corn sulfuric acid. So that is just minus H2O from alcohol. To give a product that will decolorize acidic manganese 7. I think I just shown to you there's no alcohol here, alright? There's no alcohol because what you have is carboxylic acid. Okay, carboxylic acid you don't form the alkene because you don't do dehydration with corn sulfuric acid on the carboxylic acid. So 3 is immediately wrong. Okay, but I should have started by checking 2, but because I checked the functional group out first, I already ruled out number 3. So let me check number 2 now. So number 2, if I draw out skeletal formula, there's no any other faster way. Learn to do your skeletal formula. That's the only way I can see going forward. Yeah? If you're still drawing display for your MCQ, for your structure, when they don't ask you to, really go skeletal. The more you practice, the better you get it. CH3, CH2, CH, OH, CH3. Carbon form 4 bond. So there's 3 hydrogen. Carbon form 4 bond, there's 1 hydrogen. Carbon form 4 bond, there's 2 hydrogen. Carbon form 4 bond, there's 3 hydrogen. Alright? So there's the OH. So like I said, we don't show the hydrogen in the skeletal formula, but I'm gonna show it because I want you to see that is your dehydration. So that can dehydrate to that. Of course, you can also get the cis, all right? And then they want a product that can decolorize acidic potassium manganese 7. So there is an oxidizing agent, as you would have known from GCSE and O-level, and I mean it seriously, okay? You learn oxidizing agent and reducing agent. This is the most common oxidizing agent in your O-level redox, whereas Ki is a very common reducing agent in your O-level redox changes, alright? So we know that alkenes can undergo oxidation with this oxidizing agent. So you can get oxidation with H plus and MnO4 minus, which is the same as KMnO4, okay? I'm just using the anion. So definitely you will get purple to colorless because the manganese 7 plus 7 goes to manganese plus 2 because you can oxidize the carbon-carbon alkene as part of alkene chemistry. Alright? Number 1, you have a tertiary alcohol because the carbon with the OH is bonded to 3 other carbon. So again, I'm not doing a very good skeletal here because I've shown the hydrogen, but my point here is to show you that you will get the double bond here. So in this case, there's no cis and trans because you have a CH2 terminal, hydrogen and hydrogen, same atom on the same carbon. Moreover, you have CH3 and CH3, same group of atoms on the carbon of the same carbon of the alkene. So no cis and trans at all, alright? But you still have the alkene, and you will do the oxidation product as well, and therefore you can also decolorize your acidified KMnO4, alright? Because either you're in an extreme condition, which you have seen in alkene chemistry, where you rupture, you do oxidative cleavage, where the carbon-carbon double bond get ruptured, or you use cold dilute acidified KMnO4, and you will form diol. This become OH and OH, OH and OH, OH and OH, and those are called diols. And we say both the carbon have gained oxygen, and therefore there's oxidation. Okay, so only 1 and 2 are correct. That's option B. In this next question, we have this thing called menthol. So which statements about menthol are correct? If I check number 2 first, on reaction with corn sulfuric acid. So again, we are looking for elimination of water. So elimination of water is called dehydration, but the type of reaction is called elimination, as you have covered under introductory organic chemistry, if you look specifically in the syllabus. Okay, so dehydration is the name of the reaction, elimination is the type. Okay, very specific. Produce a mixture of 2 alkenes. Well, this is our OH. Our neighboring hydrogen can be here, or it can be, let me use a different color. It's this, or it can be this. So you have 2 neighboring carbon on the carbon with the OH. It can be this or this. This and this are different. That's why I put them in different color, because this is a CH2. This is a CH. 2 hydrogen versus 1 hydrogen. How can they be the same? Cannot lah, okay? So what happened then is, if I just draw skeletal, then the blue color one will give me the alkene there, and that's the blue color product, and then the green color product will be that, and that. And there is no cis and trans in a ring structure, okay? So you don't get cis and trans, no cis and trans for cycloalkene. In this case, cyclohexene, alright? Because of ring strength, you can never get cis and trans for double bond inside a ring, yeah? So that is 2 alkene, and that is correct because this and these are different, alright? The carbon double bond is close to the isopropyl. The carbon double bond is away from the isopropyl. Isopropyl basically 3 carbon branch out at position 2, alright? So it's an isomer of propyl straight chain. There is if I check number 1, there is a total of 2 chiral center. Let me check. Looking at chiral center, I hope you can see there's 1 there, and there's 1 there, because if you see in this plane, if I split the molecule into half, this side has OH, this side has no OH, this side is different from this side. This side is different from this side, and then hydrogen is the third one, CH3 is different, 4 different groups attached to this carbon. Same deal, this side and this side are different. You have hydrogen, and then you have this group. So 4 different groups attached to this carbon. Both of these are chiral. This is not chiral because these are the same group. These are not chiral because they are CH3 and CH2, but there's one more, do not miss it. This is also CH2, not chiral. This is a carbon bonded to this bit, which are different from this bit, and then hydrogen and then OH. So there's another chiral center there. Okay, so there's a total of 3 chiral center, not 2. Number 2 is correct. Number 1 is wrong. There can only be one answer, which is 2 and 3. But that's even before I check number 3. So let me just double check number 3, okay? So acidified potassium dichromate is usually what we really prefer to use in oxidized alcohol. Alright? So do you have an alcohol that can be oxidized? The carbon with the OH is bonded to 2 other carbon. This is what you call secondary alcohol. You have a secondary alcohol can be oxidized to ketone to form ketone. If you can oxidize it with this orange colored dichromate, which is chromium plus 6, so that will go to chromium 3 plus aqueous, which is chromium plus 3, and there is a green colored solution. So that is indeed correct because you can oxidize secondary alcohol. So next question. So which structures show a primary alcohol? So primary alcohol, the carbon with the OH is bonded to one other carbon. Cannot be dehydrated. Remember, to dehydrate, you need a hydrogen on the next carbon to the carbon with the OH. Alright. So let's do number 2. So you have CH3, CH2OH. So it's just ethanol. Well, it is primary alcohol. The carbon with OH is bonded to one other carbon. And then you have 3 hydrogen on the next carbon to the carbon with OH. This is a carbon with OH. This is your next carbon. There is 3 hydrogen. So guess what? You can get the alkene and you can eliminate H2O. Okay, under suitable condition, of course. As you have seen before, corn sulfuric acid, and you need to heat it up to like 300 or 200 degrees Celsius. Okay, but that's not what is being asked here. So what else do we have? Okay, I can tell you number 1 is wrong because it's only got 1 carbon. You only got 1 carbon. To do elimination, in fact, to get alkene, you need 2 carbons minimum. Okay, to get a double bond between carbon, you need 2 carbon. You only have 1 carbon. Straight away, I can tell if 2 is wrong, if 2 is correct, 1 is wrong. Only C can be the answer, which is 2 and 3. Okay, but let's go through number 3, because in a theory paper, you will be asked to think about the product that you can get. Alright, CH3, CHOH, CH3. So this is what you call a symmetrical alcohol. This is a CH3 and this is a CH3. So it does not matter whether I remove this H or this H. They are going to give you the same product. Okay, let me show you what I mean. That is by removing this and this. Alright, if I remove this and this, I will get that. Try naming your propene. You want the lowest number, right? So that is prop 1 in. You also want the lowest number. If you go 1, 2, 3, you get prop 2 in. Prop 2 in, 2 is higher than 1. You should go from prop 1 in. They are the same. Okay? So do not get confused, yeah? Because sometimes they ask you in multiple choice how many different alkene you can get. And of course, there's no cis and trans because you have a CH2, which is 2 hydrogen on the same carbon of the alkene carbon. So you cannot get cis and trans if you have 2 atoms or 2 groups of atoms that are the same on the same carbon of the carbon-carbon double bond. Alright? So 3 is actually correct based on what they're asking. No. Cannot be dehydrated. Oh, you see? Very careless, right? Very careless. Think about it again. Cannot be dehydrated. This can be dehydrated, okay? Can be dehydrated. You see, I show you one thing and then I write another thing. Alright? Do you think you can make this mistake also? Maybe, maybe not. Alright? So this one can be dehydrated. So what am I looking at? So this one can be dehydrated. So 2 and 3 are incorrect. So 1 cannot be dehydrated, as I mentioned. Okay, because you only got 1 carbon, you can afford alkane 1 carbon. Only 1 is correct. So D is the answer. Anyway, recover in time. All right. So this is the last question of this 5-question series on alcohols. So quite a big molecule here, but we are interested in the alcohol. So the alcohol is bonded, the carbon with the alcohol is bonded to 2 other carbon. That is a secondary alcohol. So which statement are correct? We also have alkene. Maybe I should use a different color. We also have I don't mean to them. We also have alkene chemistry, and the rest of them are alkanes. All right. So when it reacts with bromine, you're going to get electrophilic addition. So imagine if I lose that thing, and then I get Br and Br, single bond, right? I can't be bothered to draw the whole thing out. Yeah, really, I can't. All right. Not when it's simple, I can just remove the double bond and then form the Br and Br. So this is the electrophilic addition. You have carbon-carbon double bond of your cholesterol reacting with bromine. And now you say, how many chiral center does this product have? Well, there's 1 chiral center there, and there's another chiral center there. And I think the key thing here is new, all right? Because originally you also have chiral here, okay? So that is your original chiral center, okay? When you break this double bond and you do electrophilic addition, your final dibrominated product also have extra 2 new chiral center. When you form the bromine and the bromine added across double bond, you have 2 new chiral center. But you still have many. In fact, this is also chiral, right? This is also chiral. This is also chiral. What else? Chiral. Yeah, you have many chiral center, but the new one is basically this and this. So perhaps I can change this to a different color. All right. So 2 new chiral center is actually correct. Cholesterol reacts with a mixture of ethanoic acid and corn sulfuric acid. I have a secondary alcohol. Oh, I don't want to do that. I have a secondary alcohol, so can do condensation. Condensation is the type of reaction specified in the syllabus. So the thing is forming ester. Okay, the name of the reaction is esterification, of course, but the type is condensation. So that's perfectly fine. You can do condensation there. The alcohol can lose the H, the ethanoic acid can lose the OH, and you can get an ester there. Cholesterol is oxidized by acidified sodium dichromate 6. So sometimes whether they use potassium or sodium, it's the same thing really. 2 of that, and you have Cr2O7 2-, which is chromium plus 6, which is orange. It can oxidize alcohol. This is our preferred reagent to oxidize alcohol, not acidified CmNO4. Although of course acidified CmNO4 can also oxidize alcohol. Alright. So this is a secondary alcohol. It can be oxidized, but it's a secondary alcohol. It can be oxidized, but it does not form an aldehyde. It forms a ketone. Alright. So 3 is incorrect, even though the first part of the question is correct. Alright. So you got to read the whole thing. So there's option B there. This is the end of this 5-question tutorial series on section B questions on alcohols. If you enjoyed the tutorial, make sure you click the button on the bottom right, subscribe to the channel, share the channel widely with friends, your class chat groups, and many other people you think this channel can benefit. Alright? So thank you for watching, and thank you for sharing, and see you in the next video.